Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Azo coupling is an electrophilic aromatic substitution reaction where a diazonium ion, ARNN+, acts as an electrophile and couples with an activated aromatic compound, here N-dimethylanilin, an amine-activated ring. Moving on to the next step. Identify the coupling partner. N-dimethylanilin is an electron-rich aromatic amine. It can couple with diazonium salts via electrophilic aromatic substitution at the para position. Moving on to the next step. Consider pH dependence. At low pH, strongly acidic conditions, the amine group of N-dimethylanilin becomes protonated to form the anilinium ion ARNH+, CH3, 2. This protonated form is electron withdrawing, deactivating, making the ring much less reactive toward electrophilic attack by the weakly electrophilic diazonium ion. The reaction is therefore inhibited at low pH. And for the final step. At high pH, strongly basic conditions, the diazonium ion itself is converted to the diazohydroxide or diazotate, ARN is equal to NO or ARN is equal to NO-, which are far less electrophilic than the diazonium cation and do not couple efficiently with amines. At intermediate, mildly acidic to neutral, roughly pH 5 to 7, pH, two conditions are simultaneously satisfied. A. The diazonium ion remains intact and sufficiently electrophilic, and B. The amine coupling partner is predominantly in its free base, unprotonated, form, keeping the ring activated toward electrophilic substitution. This dual condition at intermediate pH enables the C-N-azo coupling reaction to proceed optimally. Why other options fail? A. Low pH, amine is protonated, ring deactivated, coupling does not occur. C. High pH, diazonium converts to non-electrophilic diazotate, coupling does not occur. D. Any pH, the reaction is pH dependent and does not work at all pH values. Therefore, the correct answer is B. Therefore, the correct answer is option B.